Hello everybody, welcome to Statistics and Theory. I'm going to discuss validity and present a very brief history of validity throughout the years. As you see in this slide, I have divided the history of validity into several milestones, but this is not something that everyone might agree upon, and different authors and scholars might have a different idea. But this is based on many of the papers that I have read so far, and I think there is some sort of agreement about the importance of these milestones in the history of validity. So let's get started. Uh, Before 1955, right here in the left side, on the left side of this diagram, validity was represented in a variety of ways. As Guyon 1980 referred to it, there were three types. So I write Guyon's name here. I hope you can read this. 1980. He said that there was a holy trinity in validity research. And by this, he was referring to the 3C sort of validity. And what are the 3C validities? Um, well, the first type of validity that he was referring to is basically known as content validity. And by content validity, we mean the resemblance of the content of your test to a TLU domain. I discussed this in the previous video, so it's closely related to the concept that I mentioned before. I'll provide a link to that video here right on top, and also at the bottom of this presentation. That's in the comments section, so you can watch that video. I suggest that you do. I think it will be quite useful. So content refers to the resemblance of your test. Let's say your test has got a few items in it or tasks like this with the target language use domain or the TLU domain. So they have quite a lot of tasks here, and you select a representative sample of these tasks in the TLU domain to include in your test. That's basically the idea of content validity. So as other authors have argued, content validity is established if a group of experts basically look into the content of the test on this side and compare it with the content of the TLE domain. And ultimately, they make sure that there is a good coverage and relevance in the test. So these two are also important. This is what Samuel Messick has discussed. The second type of validity that is within the Holy Trinity, so-called the Holy Trinity framework, is criterion validity. So criterion validity is the relationship between the test itself. So let's say this is your test, the test that you've developed, and another measure or another criterion. So let's call this measure or observation that's intended to tap into the same latent trait or the same construct. By tap into, I mean to measure it. But to tap into the same latent trait or the same construct as your test. So for example, you have developed a test of reading, and you administer that to your students, and then you score the performance. Then you compare the performance on your test with another test that claims to measure the same construct or the same kind of ability, which is also reading. So there should be a connection or a good correlation between a good correlation between these two measures. So that's what we mean by criterion. There are two types of criterion validity. One is known as concurrent validity, and the other one is predictive validity. They are different in the sense that if you are comparing the results of your test against the results of another test, that's the performances of your students on both tests, almost concurrently, where you refer to this as concurrent. For predictive, we usually uh, want to investigate the relationship between test performance and a future non-test performance. A very famous example in language assessment is, for example, test takers take a test of language proficiency, and then their scores on this language proficiency are correlated with their language performance in academic contexts. Uh, as an example, their language ability in academia or something similar, or like the quality of their essays that they write in an academic program, etc. That's the idea of predictive validity. And finally, construct validity. Construct validity basically was mainly discussed around 1950, but people had started to talk about the importance of constructs even before 1955. So by construct validity, uh, an earlier group of authors meant whether the test measures what it's supposed to measure. For example, it purported to measure the reading ability of test takers. So the construct validity would be whether the test actually measures reading ability of test takers or something else besides reading ability. Construct validity, however, um, its definition and conceptualization has changed over time, and as I will talk about it in the next step, um, you'll see that it has become one of the fundamental concepts in the history of validity. Now that brings me to the second step, or second stage, in which one of the most influential papers in the history of validity was published by Crumbach and Miel, 1955. The idea of um, this representation of validity revolves around what they called the nomological network of validity. The idea of nomological network is a bit complex, but I think it's quite a useful way of conceptualizing validity. Let me draw a line here between the previous one and the current one. Nomological validity or nomological network of validity has to do with the relationship between the construct and other similar constructs or dissimilar constructs in a network. Nomological means law-based or rule-based, if you will. So our construct is, let's say, a reading comprehension. This is what we want to measure. Now, there's always a relationship between the main construct we are measuring, that's reading, and other constructs, let's say vocabulary or grammar, and even listening. So these are creating a network like this, and they are also connected to each other. And the more we understand about the construct and we include related concepts and constructs, the more comprehensive the nomological network becomes. This is not an exhaustive list of constructs that are related to reading right at the center, but you can think about other things, for example, executive functioning, that can be divided into several sub-dimensions, such as working memory, inhibitions, and other dimensions of executive functioning, depending on the theoretical framework you're referring to. And you might hypothesize that it also has some impact on the main construct, which is reading comprehension. The reason is, if you have watched my previous videos, is that executive functioning and especially working memory is regulated or subserved in partly in our prefrontal cortex, and so is reading comprehension. Of course, reading comprehension also draws on other language areas like pre-Sylvian um, network or um, the left hemisphere of the brain. But importantly, it's subserved. The process is subserved in the prefrontal cortex as well. So that idea actually gives us some theoretical framework to develop a nomological framework. But I need to stress that Crumbach and Meal did not refer to the neurological aspects of test taking. And what I'm adding here is just to help you, uh, build upon this nomological network theory and make it more extensive and related to what neuroscience has also discovered in the past few years or past few decades. This is the idea of nomological network. Therefore, validity would make sense if you can find converging relationships between reading and listening. On the other hand, there are some other constructs which are not supposedly related to reading comprehension directly. For example, something like math. I mean, uh, whether or not someone is good at reading should not really affect their math performance significantly. So there is a sort of reverse or no connection here between, not reverse, but really no connection between reading comprehension and math. So you can include math or other uh, constructs within this network just to show that reading is distinct from this group of constructs, but it is closely related to another group of constructs uh, altogether, giving rise to what we call a nomological network. A nomological network is not static, it's dynamic, and the more we learn about that construct that we're measuring, the more comprehensive that nomological network becomes. So that's basically the main idea that was proposed in 1955. Um, then comes Lovinger, 1957. Uh, Let me clean this part of the screen to continue to talk about Lovinger. So Jane Lovinger's idea of construct validity is related to the trinity which I mentioned before: construct, criterion, and content uh, from one perspective. But from another perspective, if you look at the model that Lovinger presented, you see that there are some differences as well. So let's go through the model of construct validity as proposed by Lovinger. She said that construct validity has three types or three components. The first one is the substantive component. Substantive component of construct validity, which basically is almost exactly the same as content validity, but she actually uh, extends it in different directions and adds on more content and richness to the idea of substantive validity. Um, the way that Lovinger referred to and defined substantive validity was based on an analogy which she referred to as universe, which I mean I used a similar analogy in one of my previous videos. Universe of tasks, or universe of in this context language, and pool. So the pool is a representative sample of the universe. For example, your universe is a universe of reading texts, all reading texts that apply to a certain group of people, say secondary 1 or secondary 2 students. And your pool will be a representative and of course a much smaller sample that has been drawn from the reading texts in the universe. That's what content validity, or the substantive component of validity in Lovinger's model, is. The second one, according to Lovinger, is structural component. And structural component is a bit slightly more complex than what we have discussed so far. So let me just give you some, provide you with some elaborations on how structural component can be defined. Structural components refers to the structural relationships between items um, and their parallel in uh, in the universe, or their parallel in another manifestation of the trait. So let me here visually represent it for you. If you have a group of items and they're measuring two reading processes, top-down processes and bottom-up processes, and these are items that are measuring them, these rectangles. Let's say we only have 6 test items, or 6 tasks, if you will. I mean, sorry, what happened to? Okay, sorry. Okay, so I pressed the button by mistake. So this is in your test, and you're assuming that this group of items is correlated with this group of items. Now, structural component assumes that this sort of relationship holds in another manifestation of the trait. What do I mean by manifestation of the trait? It could be another test. For example, another test of reading, which is also testing the top-down processing and bottom-up processing. And whatever test items they have, they might have more than 6 test items. They might have 7 or 8. Here I assume that it has 3 plus 4, which is 7. We assume that this group of items relates to another group of items. That's one thing. So it's about the correlation between items. Now, what I would like to add to this idea is that in addition to the resemblance of this correlation between the different components of the test, like this and this and this and that, we also need to find a relationship between the difficulty, or the hierarchy of difficulty of items across the two tasks. For example, here item 1, 2, 3 might be more difficult than items 4, 5, 6 on average, which means that top-down processing might be more difficult than bottom-up processing. We should find a more or less similar relationship between the items that are tapping into the top-down processing and bottom-up processing in the second test, or another manifestation of the trait. So manifestation of the trait is kind of fanciful word for another test or another measure, another type of measure. It could be a test, or it could be what happens in the TLE domain, really. So this connection should be held there between the two. The way that we could look into this analysis is the way that we can examine the structural component is, for example, composed of correlation analysis, or if you are familiar with more advanced statistical analysis, structural equation modeling. In this channel, I have created several videos on structural equation modeling, so I suggest that you take a look if you have some free time. The last component of this model by Lovinger is called external component of validity. An external component of validity, if you recall, is similar to criterion validity. Actually, it's more or less the same thing, because Lovinger also divides external validity, pretty much like criterion validity, into concurrent and predictive. So you can pause the video here and rewind it a little bit to get back to where I was talking about concurrent and predictive validity, it's more or less the same concept. So that's all, more or less everything about the major conceptualizations in Lovinger's theory of construct validity. And then comes Campbell and Fisk. Campbell and Fisk appeared on the horizon proposing their uh, multi-trait, multi-method approach to construct validity. So this is the third approach to construct validity they were talking about here, MTMM. It's quite quantitative. So we need to have some background in quantitative data analysis, at least on correlation. Long story short, the idea is that we should test or measure a trait with different methods. Let's say method 1, method 2. That's one part of the idea. And if we do so, there should be a significant correlation between students' performance on the test that is using method 1 and the test that's using method 2. For example, you test reading comprehension through giving the students MCQs versus reading comprehension through giving them open-ended questions. Since you're testing the same trait or construct, that's reading comprehension, there should not be a very significant difference between the performance of your test takers across the two methods. That's one idea. So in this case, we have a monotrait multi-method. So mono means one, trait. Okay. Multi-method. It's represented as a triangle in the main MTMM model of Campbell and Fisk, but I'm not going to draw that triangle. I think the most important thing is the concept itself. When you're looking at a monotrait multi-method assessment, we assume that there is a high correlation. So this arrow that's pointing up means there's a high correlation. On the other hand, when you have two traits, trait 1, trait 2. For example, mathematics is trait 1 and reading is trait 2. Regardless of what method you use, for example, you might use the same method or different methods, MCQ or anything else, these two should not have a high correlation. Why? Because the traits are different. So we do not assume that they have a high correlation. For example, whether or not I can swim should not really affect my ability to pass a reading test. To give you a very extreme sort of example, because there are two different traits. So here we're looking at multi-trait mono methods, multi-trait mono method. So there should be a low correlation there. Now you can manipulate these and come up with other permutations. For example, multi-trait, multi-method, and that's definitely a low correlation. Then monotrait, monomethod, that's also high correlation, in other words. So that's the idea. If you find these sorts of correlations, then you can claim that the construct validity of the test is supported. Now, if your test correlates significantly highly with another test that measures the same variable here, like this one, we can call this the convergent validity or convergent validity evidence. Why is this so? Because the performance of students on two tests, test 1 and 2, converges. On the other hand, we also need divergent or discriminant validity. They should diverge. Divergent, okay. Divergent validity. And this divergent validity, as you can guess now, has to do with the correlation between those multi-trait tests. So the performance of students on tests that are measuring different traits should diverge or should be different. The example I provided applies here. Uh, I should find a very weak or no correlation between the ability of my test takers to read a passage and their ability to swim well, because they have nothing to do with each other. So that's called divergent evidence of validity, and that's well, basically everything that more or less everything that we will need to know about Campbell and Fisk for this video presentation. Next comes Messick. Messick has a long history, and there is a lot that we can say about Messick, and of course related to Messick is Crumbach. Lee Crumbach and Messick are two towering figures in the field of validity and validation. Two of the main takeaways that Messick and Crumbach stressed, and which actually differentiates it from the rest of the theoretical frameworks I've discussed so far, is their stress over two concepts: interpretations and uses of test scores. So far, most of the concepts that I have presented are mostly about the interpretations of test scores rather than uses of test scores. And interpretation is, what do the test scores mean? For example, the test scores mean the reading ability of the test takers. Or you can break it down further and you can say the test scores mean the top-down and bottom-up processing abilities of the test takers. But then those test scores are usually put to some uses, according to Messick, Crumbach, and people after them. These uses are mostly, for example, decision making, DM for decision making, and also they have some consequences. As a result of the decision making, there will be some consequences for the students and for other stakeholders. And Messick and other people after him, and especially Crumbach and of course Kane and a lot of people in language testing, have argued that the uses of test scores should be considered as a very important component of construct validity, or validity, if you will. So I stop here, and I will talk about Messick later a bit more in more details. Finally comes Embertson. Before I talk about Kane, I think I will have to discuss Kane in a separate video because there will be a lot to talk about Kane. So Embertson proposed the idea of nomothetic span, which is very similar to nomological network. So if you are already familiar with nomological network, which I mentioned before, you can say that nomothetic span is more or less the same, and it just like nomological network refers to the network of relationship between similar constructs and dissimilar constructs. So you can put together convergent and divergent validity, and you can get a nomothetic span. One of the best ways to look into the nomothetic span of tests is to use structural equation modeling. Before finishing this video, I just wanted to walk you through Messick's unitary concept of validity quickly, and to show you that most of the concepts that we have discussed so far are represented in Messick's 1989 book chapter. He basically adopted these concepts into his framework and called them the unitary concept of validity. Since I've already discussed them, I think it's much easier now to make sense of them. One is content. This is content validity, if you recall. And Messick defines it in this way. Do test items, or questions, if you will, appear to be measuring the construct of interest? And as I mentioned before, you can actually pause the video and rewind it and go back to where I talked about the relevance and the coverage, construct coverage or content coverage and content relevance are two major subcategories of content. Then generalizability has to do with this question. Does the test generalize across different groups, setting, and tasks? For example, if you give the test to a group of male versus female test takers, is the test on average of the same difficulty level for the two groups, or does it advantage or disadvantage another group? And across different tasks, for example, you have different versions of the same test and you administer the different versions to the same group. Well, those versions should not be very different in terms of their difficulty, etc. I've already talked about structural and substantive and external validity. These are, as you can now guess, have been adapted from Lovinger, and structural refers to this question: do the interrelationships of dimensions measured by the test correlate with the construct of interest and test scores? The next one is substantive and is defined in this way: is the theoretical foundation underlying the construct of interest sound or not sound? And external is the test. Does the test have conversion, discriminant, and that's actually divergent, and predictive qualities? And I've talked about this before as well. And finally, about consequence or consequential validity of the test, which is conceptualized within in this question. What are the potential risks if the scores are invalid or inappropriately interpreted? Is the test still worthwhile given the risks? And this is another important question that pertains to the uses rather than interpretations of test scores. And that brings me to the end of this presentation. I will discuss Michael Kane's framework of validity in the following video. I hope you have enjoyed this video. If you did, please give it a like and watch the next video about argument-based validity. Thank you.